exact same thing here. And that is a great stopping point. We'll go to the capstone, we'll go through it. It's a great midway point to test your skills. If you get through the midway point and you say, hey, I really like this, I want to get the rest of the course, we have even more stuff in here. We have Active Directory, which is one of my favorite things to pen test against. And I would say it's the best part of the entire course. We teach that. We cover quite a bit of this. All this is on cover more cover web app pen testing, application pen testing. We get into a little bit of documents and all that fun stuff. So here, it's a great resource. It gets you started. If you love it, you want more, this course, all of our courses, in fact, on the all access to everything. We've got courses on Linux. We've got courses on privilege escalation, OSINT, external pen testing, all different kinds of stuff in here. If you're interested in that, I just encourage you to check out the website. You don't have to buy anything. This is completely 100% free if you just want to stick with the 15 hours. Last but not least, this course does lead to what is a certification. We have a certification called the PITS, the Practical Integration Testing Certification. I'll link it down in the description below. It's a one-of-a-kind certification. Go through, hack an organization. You write a report, you present a debrief, and the good thing about this certification, you actually go look for the PMPT on LinkedIn or Indeed. You're going to find this on job postings. So this PMPT as well. This 2020 there's like pen test that we perform. Or internet. There are scanning the internet 24/7. If you don't believe me, try putting up for 20 and see how many login attempts you get on the server. It's a lot. Incredibly dangerous, a lot of work. It's pretty usually organizations put their external networks up from making perspective. Look the intel that we can gather. Where are the login panels? Who are users? Most common type of test that organizations do, in my opinion, for two reasons. The reason is that a lot of compliance organizations dictate that an external network pen test be performed annually. That is not true. Though some compliance organizations might dictate other pen tests, they tend to be a little bit cheaper than the side. In the out. Average, you have a very large engagement that can go all small at one IP address or 5 IP addresses. Probably not 32 hours to do that pen test, maybe somewhere 8 to 16 hour range. Then 10 to 16 for report writing. And we'll touch base on writing at the end of this. So moving on is what is called the this means somehow email clicked on and we broke range. And just like external pen tests, we tack on another 8 to 16 hours for writing. Now, the third type of assessment I wanted to talk about is this is probably the second most common. I wanted to internal pen test together. But you have to think about networks nowadays versus web applications. There are websites everywhere. There are more websites than there are networks if we're just counting websites to business networks. There are probably more websites to home networks as well, though I'm not entirely sure of that. I would argue that the answer is probably way more websites than home application pen tests. This can be dictated again by perhaps stakeholders want to see this, or maybe the client is very interested in the security of the application and wants to make sure that it is very heavily on web-based attacks, obviously, and OWASP testing guidelines for the Open Web Application Security Project. If you've never heard of it, Google it. It's a great testing guideline, not just application, but mobile as well. They follow guidelines pretty exclusively. For sure, you'll be asked these engagements last and very and test hours very small and significant form as pen tester, wireless pen test, or a wireless network pen test. And we're assessing an organization's wireless. So the methodology will vary depending on what type of wireless network is being used. For example, if they're using a guest network, we might log on to the guest network and test segmentation. Can a guest access internal resources, or is the really changes depending on what is being used. Now, wireless pen testing is fairly straightforward. You can look up the methodology online, find a blog post about it. You just need to pick up for $50 at most, and all below the network. You just want compatible with where it's one of those things that about 8 hours. The client might say, hey, or they might say, hey, I want you to get in the building and though often they're left apart. We might do something like a phishing campaign where we call people and we say, hey, I'm from IT. Can you give me, or I just sent you a code to your account. Can you give me the code that I just sent you? We might do a smishing campaign where we send text messages and see if anybody responds back to us. There's a lot of different social out there, and we have different campaigns run in different engagements depending again on the client's need. Now, the great thing about this is social engineering and physical pen testing offer a lot of learning opportunities. For example, when we wear cameras on our hip and we record you, not just for our users at the end of the day. We'll cut that, have a did, here's the bad thing they did, and they can walk away with a way to improve moving forward. The weakest element is a great environment, great policy, security, everything set up, and all it takes is one really nice person to hold the, and that can lead to catastrophic events. So social engineering, again, is a very important part of security for things to assess when I'm doing this type of work. Now, again, these can last anywhere 16 to 40 hours, even more, depending on the engagement that you're on, plus 4 to 8 hours more, depending on the scope. Now, these aren't the only assessments. There are other assessments that we might perform as a pen tester. These tend to get a little bit more specialized, and you might have to take additional training in order to learn this type of stuff. But these are things that we perform at work, and you may end up performing as well. So we have mobile penetration testing. It's a location penetration testing related to those operating systems. T or Internet of Things penetration testing. Somebody might send you something. Like one time we got sent over a cooker that was a wireless pressure cooker and they wanted it pen tested. So we had a lot of fun doing that. There's red team engagements, which are kind of sort of pen testing, but not really. What I say pen, I think of banging at the front door, where red team is trying to sneak in whatever creative way you can. So a red might say, hey, we want you to hack our company. You've got a month, and we don't want to hear you. We don't want to know if you can hack us. In these types of engagements, the methodology can be anything depending on what is allowed in scope and the scope. I've heard of red teams sending people to the client location, and they might even live there for a little bit. They internal secrets, maybe get a password, slip them a thumb drive. They might do all kinds of social engineering engagement. It's very, very custom and unique to the client. It depends, again, on this, usually pretty wide, and what they can and can't do. So red team engagements are pretty awesome, but they're also incredibly stealthy, where pen testing is very time limited in the sense that we might only have a week engagement. We're going to know the IP addresses, we're going to know our scope, and we're going to have a set defined in front of us, where red team doesn't have that. Now, a purple team engagement is something that you might do, tabletop exercises and things like that, where you as a red teamer and working with a blue team or defensive, you work together, and that makes purple. And in that sense, you might tabletop and say, hey, I just ran this attack. Do you see me in your network? I just ran this other attack. Do you see me? And you try to establish, and you can see, hey, how can we improve detection mechanisms within the network? It's usually a bit of a more mature process. An organization that's never gone through a pen test before likely is right into a purple team engagement, but it is something that more mature organizations do in order to improve their baselines and improve their detection mechanisms internally. Cover just a handful of the different types of pen testing and gone. There's car hacking, there's airplane hacking, there's SCADA hacking. There's all kinds of really cool stuff out there that you can do. I just covered the items, but you can absolutely specialize. That's something that you're interested in. Now, with all the fun of getting to do assessment work, there comes the downside of report writing, debriefing. I actually enjoy doing both, and in order to be a successful consultant, you really need to be a three-headed person. You have to be really good at technical abilities. You have to be really good at report writing and communicating effectively, not just a technical audience, but to a non-technical audience. And you also have to be good at presentation skills, and in the sense that you need to present your technical and non-technical audience. So with report writing, we typically deliver a report in a week after the engagement. Now, that report should be high level and technical. So we have what's called an executive summary for non-technical people. Think about a CEO who might not be a technical person. If they're going to read the report, it should still hear what the issues were and how they should be fixed. And that's what the executive summary. Now we have a technical finding, and that's for the people doing the work. Maybe the security engineer, the network engineer, or the web app developer, who working with, they can digest the findings. They can say, hey, here's what they found, here's what tools they use to it, and here are the recommendations for remediation. Now, it should be incredibly clear. You should have high-level recommendations like, hey, patch this. And you should have technical recommendations as well that says, hey, go to this website, here's how you would install this patch, etc., etc. So depending on your audience, you want to make sure that you're communicating effectively to both of them. And for a lot of new pen testers, this can be an incredible struggle. It's one of those things that you write a report, you get beat up in the QA process, and you just get time. And it's just something that is current as you go. Don't be worried if you're not great at report writing. Just make sure that you understand that if you're going to do this job, you will have to write reports, and you will have to get better at it as you go. Last but not least is the debrief. Now, a debrief walks your clients through your report findings. And again, this should be non-technical and technical as well. You may be sitting in a room with a network engineer. You might be sitting in front of all technical people. You might be sitting in front of all technical people. So you need to make sure that when you are presenting your findings, that you can explain it at a high level and a technical. I've seen many people struggle with this. All right. I've had in one situation, I remember that brief with a coworker of mine. This was years ago. He was very much struggling to communicate. He was technical, in-depth details about what he was finding. And the CEO kept stopping him and saying, I don't understand what you're saying. So we had to do a little bit of translation. Really wasn't great at the debrief process yet. He was still fairly new. And it's one of those things that if you're going to be an effective consultant, now the debrief is because of the opportunity for your client to ask in the initial report, the report is a draft. After the debrief, or if they choose to not have a debrief, we finalize that report. So the debrief is the last opportunity to understand what you're presenting to them and to ask any questions or address any concerns. So it's a very, very important process. All right, hopefully it's informative for you. If you're looking to become a pen tester at a high level, what these different types of assessments, and you should know what you're getting yourself into, because a lot of people think, oh, it's fun and games. I just get to go hack things. And yes, that's a lot of the job, but a lot of the job is also you're not strong with report. You may have some time on the struggle bus before you get decent at it. All right, so make sure that you know coming into that those are things to be doing and that you're comfortable doing those things as well. So before we begin this course and we really start to dive in, it's important to cover one of the topics, which is effective note keeping. If you're going to be successful in your career and you're going to be successful in this course, you really need to take notes. Now, in this, what my notebook kind of looks like, not only for a notebook for an assessment and how I might take notes for an assessment, and then I'll also show you some note-keeping applications that I prefer or I've heard students. In the second video, we're going to cover how to install one of the applications and another cool application used for screenshots. So let's take a look at my notebook first. So here is my notebook, and actually let's click over here. So this is my notebook, and you can see it's really long. It's got all kinds of stuff in here, and it's just something that in particular is actually only geared to Active Directory. So I have a few different notebooks. This one is Active Directory, and it's actually a few different courses that I've taken in the past that I've kind of put together. And then just for assessment work, etc., I just show you this one in particular because these were built off of courses, and you so kind of just get an idea of how maybe to structure it. And I've got different modules here where, okay, module 1 might have had this email macro fundamentals, module 2 is different components to them, right? And we have child notes and even sub children to those child notes. And I'll show you how to create that here in a second. But let's say, for example, enumeration, which is one of the most important that you're going to cover in hacking. And we take a look at enumeration. You don't have to understand what any of this means here, but you could see if I want to look at a domain and I want to get the current domain that I'm on, here's the command I run. And here is a picture of what it looks like, and here's what comes back when you run that command. That's great. That's what I want to see. And I have a whole list of commands for all these in here, right? So on a assessment, I want to go and find a command that I'm not sure of, I can go to my little cheat here. Now, again, this is really long, really helps. Of course, I think it's good to write it all out step by step like this, and then make a cheat sheet. I don't need these pictures anymore. I've been doing this for a while. So maybe I just say, hey, get current domain is get net domain. And then I say, hey, okay, get object of another domain, an example of it. I don't need the pictures because it makes it really long. But as an example, and you learn with the pictures as well, at least I do. So let's build from that. Here of an actual assessment that I did for a client, a web application assessment for the client, and the finding. Now, I'm only going to show you this map. Here, one example is on the internal. They had the picture has highlighted as, hey, message signing disabled. That signifies SMB signing's disabled. And it has the IP address. So we ID and we get proof of concept that this SMB signing is disabled here. Another example. M01 internal exploit your course. Here is this, but it shows that it's actually vulnerable to this attack. So these are a couple screenshots that I'll put. Now, your notes could be different than mine. How I organize is I take a screenshot, I put it in here, and then I make sure the IP address and the screenshot for reference because I'll remember it. But if you need to go in here and detail notes, you always want to know it's going to come back in 6 months or even a year and say, hey, what was that thing that you did here? Go back to your notes. Oh, you know, I did. And some people get down really into the weeds. They have time, everything, and and how well you take your check marks when I report out, and I cover in the report and change that I've written that part of that finding, and we just kind of go through over time. Being said, I do want to show you some applications. The one that I'm using is called KeepNote. Now I run it as a base. So KeepNote, it is for Linux, it is for Mac OS X, but this is totally a preference thing. I prefer it. I've been using it for a long time. Some people don't like it. Okay, so I'm going to offer some alternatives as well. It comes built into Kali Linux, as you're going to see here in just a little bit. Worth looking at, worth trying, seeing if you like it. It's another example if you use Microsoft. And if you're a Mac user, a lot told me that Joplin is really good. Now, I've never used this. Great things about it. So what I'm going to do is I'm going to put all of these into the course resources, and you'll be able to look at them by any means. Feel free to use whatever you like to take notes. If you want pen and paper, that's great as well. And so just make sure that you're taking good notes. And we're gonna harp on this throughout the entire course over and over and over again. So make sure you're taking good notes. So from here, what we're gonna do is we're going without it. So let's go to the next work on using heat. So I think come here and so great. This tool is it has not been a long time. Some people find one of those people. I'm actually not. You can cherry tree is also an option. You can also find other options out there for you. If you have a favorite note-taking tool already, that's absolutely fine as well. Just make sure to take good notes, especially during this course, and make the most of it. All the things that you can and include that. So I will show you. And another thing is available. We're going to Linux very soon. Linux, we explore more cherry tree. Programs of cherry tree. So here, you follow along, or you appropriate one here, depending if you're on Linux or if you need Mac as well. So I'm going to go ahead and install the exe, and I'm just going to actually run this. We're just going to say yes, and I'm going to say next, next, install, and that's it. That, I mean, it's that quick. And then note, and here you go, we've got keep note. So the other tool, the really cool tool that I love, this one is called Greenshot. Now this is a screenshot capturing tool. So let's go to downloads here on Greenshot. If you are running on something other than Windows or Mac, so basically Linux, you're going to need a different tool. The recommended tool that I've heard out there is called Flameshot, Flame. I have no experience with it. So here I'm going to download the latest stable. I'm going to select run. Yes. Okay. Accept the agreement. Give away our firstborn. Next, next, next. Place it however you want. I'm just going to net everything, and I'm going to start Greenshot with Windows. It's finished. All right. Let's take a look at it. So it should be running now. Okay, now you see it running down here on the bottom. Okay, let's go. Let's open up a web page. Let's say we want to take a screenshot of something. Now you just hit your print screen button, and this nice cursor gets brought up here. And let's say we want to just take this downloads part right here. We're just going to capture this. And now we have choices. We can just save the image that we just grabbed. Or my favorite is that we can actually just open it in an image editor, right? So let's open this in their image editor. Look at this. Okay, so you just grabbed, right? On top of this, really great tools. Let me show you two that I use always. So I come into effects, I put a border on it. Let's say that you have like a Kali Linux, and Kali Linux, if you've never used it, has a black terminal. It's really nasty. So let's imagine here that it's black. It's nasty when it comes to reporting. So let's imagine that we're in this situation and we're writing a report and we've got this black background. Well, you can see what I just did. I just inverted it. And I do this for all of my reports. I invert the Kali background. So that way it's white. And that way it looks nice on a report. And when we get into the reporting, you'll kind of see what that looks like. But I like a nice clean background. It saves on ink as well if they were to print it. And it's just nice and neat when you give it to a client. So I always invert my images if I need to. You've got the black border here. Another thing is, let's say you want to point something out. You saw in my keep note notebook that I have a highlight. You can just click that button, highlight something here. Great. Another tool that's obfuscate. So let's say that there's like a password or something really sensitive in here that you don't want the client to see, or you don't want to reveal on a final report. You can do that, and then you can just like up the pixel size on this and make it really blurry, you know? So it's a really, really great tool. And then when you're done, you can copy it to your clipboard. You can save the file. I just usually like copy this, and if I want to go paste it, like, you know, make a new notebook or whatever, I'll just paste it in my keep note and just kind of go from there. So again, fantastic tool. Awesome to use. If I had two for your note keeping, it's Keep Note and Greenshot. I had to make one recommendation out of the two. It's absolutely Greenshot. You can be flexible on your note keeping tool. So again, hopefully this helps you. Again, please do take good notes through this course. You're going to find yourself wanting to know, hey, what was that command I ran again?
And because we're going to go through so much stuff by the time this is all said and done that you're going to want to remember it. So please take good notes. So from here, let's go ahead and move on into our networking refresher, and we'll catch you in the next video. Hello everyone, and welcome to this section on networking. So this section is titled Networking Refresher, meaning that might have a networking background. And if you're looking at this list that's on the screen and you go down the list and you say, yep, I know all those, you can feel free to skip this section. If you've taken some of these in the past and you just might want a little bit of a refresher on them, then this section is for you. We're going to cover these topics not totally in depth, but we're going to use it as a way to brush up, and then we'll hit on networking again when we get into introductory Linux. So if you are unfamiliar with things like TCP, UDP, and the three-way handshake, or if your subnetting's a little shaky, chances are you should probably stick around and just click through this series, watch it, and build that foundation. Remember, we talked about one of the core foundations of pen testing being a strong networking background. This is a good way to build it up, remember what you might have forgotten, and go from there. So let's go ahead and just jump right into the first video, which is going to be IP addresses. What's up, everybody? So I'm going to preface this video really quick with that it is raining pretty hard here. So if the soothing sounds of the rain put you to sleep during this video and you can hear it, I'm very, very sorry. But the show must go on. So what we're going to be doing today is we're going to be talking about IP address. Now, if you've ever used a computer before and you're anywhat familiar with IT, you probably know what an IP address is. But I want to take this a little bit deeper in theory on why we use IP addresses, what types of IP addresses are out there, and talk more about protocols and how IP addresses are actually designed and made up. So I'm here in a Kali terminal. I'm just going to type in a simple command, and that command is ifconfig. Now, if you've used Linux before, this might be familiar to you. If you used Windows, it's similar to ipconfig. All I'm trying to do is bring up address. So what we can see here is that we have an IP address, which is our inet. This is my IP address here. I also have another IP address, this inet6. This is what's called an IPv6 address. So we've got this inet, which is considered an IPv4, and this inet6, which is considered an IPv6. Now you can notice right away that there's two different types of notations for these. This inet here is in a decimal notation, and the IPv6 is in a hexadecimal accordance of that in just a second. So when it comes to IP addresses, this looks probably pretty familiar to us. This is an IP address. This is how we communicate. We communicate over layer 3. Talking about layer repeatedly throughout the course, or at least throughout this part of the course, so that we can get familiar with how we're actually doing this. So I want you to be familiar with troubleshooting these layers, and these layers all refer to something called the OSI model. So when we talk about layers, we think about the OSI model, and I'll introduce the OSI model here in a few videos, and it should all introduce the OSI model. So if I brought in the OSI model up front, it might be boring, might not make sense. So I'm going to introduce the OSI model near the end, and you're going to say, hey, yeah, that all makes sense. So what we've got here is and this is the most commonly used format that we use today, right? We use mostly everything. And again, this is in that decimal notation. So when we see this decimal notation, it's just realistically a bunch of ones and zeros that are put together so that we have this human readable format. Realistically, all we're seeing here too, this section here, this octet, is actually just a bunch of ones and zeros. It's 8 bits. So we've got a range of ones and zeros here. Here, 8. And all said and done, is made up of 32 bits. 878 period. Okay, 1 second. We've got 8 ones like this, and then we'd have another 8 not going to be there. Nice, guys. So iterations of really quick. Right now, when we get into subnetting, a lot. If we have a 1 for each of these sections, the computer's 1 0. So we're going to do a little bit of other theory, IP and Y for and let's about IP4. With IP4, we have these 32-bit locations. If you take 30-second power, the possible amount of IP addresses we could have. We have somewhere in the 4 billion range of IP. Well, only 4 billion people on Earth. There were 7 billion addresses are. Well, before it's been around since 1981. Nobody thought computers weren't paying. Companies started buying them, and they started buying them up in large chunks, and sold ISP. And so addresses have been very, very, very long. And when you IP address and you this IP, you're only going to corporation amount more, but we have a lot of IP address space. No. So let's come up with IP6. And after that, I can't how to say we're going to try, but I can't guarantee you that in our life. So we the solution of it's just a thing that we this is a sign IPv4. Well, possible if we're using IPv4, but we're out of address space. Well, think about it. Using something called NAT, which is Network Address Translation. Now, let's think about a network. So you might have a cell phone or computer, multiple network has I've got multiple cell phones, smart TVs, every connected to my internet. It's an IP address, and that's 20 IP addresses right there. 10 those are 268 is not in already Google said the second issue, I think there are now we're not too weird those look class C. This is the most common household and small business use. So we see 168 address, you can get your as a proper address after number between 0 and 55 and number between 0 and 255. Wow, go to 255 without only something. $57, 130 into that class C. All these devices on this 191.6 network, all devices are talking out of one IP address. That is my public. That is what I rent from my ISP, and all this network traffic, one IP. So this is what have achieved solve the issue of running out of address space without having to use IPv6. Not that there's anything wrong with IPv6. It's not pretty. I mean, it's way easier to type this stuff in than it would be to type something like this in. But at the same time, this is how we've solved it. We're able to out with this quote unquote IP address shortage. So hopefully that makes sense. We're going to build upon these concepts. Again, IPv addresses are layer 3 protocols. Layer 3 is a router. So when we route traffic, we route via an IP address. So we're going to build upon that as well as we go in. Hopefully this is all just a refresher to you. So that is it for this video. I'll catch you over in the next one. All right, so we're going to move here and talk about layer 2. So remember, IPv6 IP addresses, so that is layer 3. We're talking about routing. Here in layer 2, we're going to be talking about a MAC address or a physical address. Now, media access control here, FFig, as this ETH here. So when we are using this physical address, how they know what device is what. So what we say here is if we have a device, say you just built a computer and your network interface card, or you're going to plug that in and you're going to have a address for that NIC. Your cell phone, that's going to have a MAC address. It's using a network interface is going to have a MAC address. So these MAC addresses are there's something to it briefly about MAC addresses. Now, MAC addresses have identifiers. So as you can see here, this MAC address has 6 different pairs of 2, right? And what we can do is we could take the first 3 pairs and we can just copy this, and we can go out and we can try to put a MAC address lookup. Now for this one, this is just going to be, I'm not sure if it's actually going to come up, but I'm going to go ahead and paste it and see what happens. And you can see that the vendor actually shows up as VMware. So the first 3 pairs here are identifiers, and we can identify what we're up against. If you've ever you've looked at your network and you're trying to find a device and you see the IP address, but the IP address doesn't really help you identify it. You might see something along the lines of a MAC address, because your home device, say your router, might also be what's called a layer 2/layer 3 device, meaning it's doing switching and routing and it'll also know the MAC address of that first 3 machines. See if you can identify what that device is. So if I was unsure, this didn't have a host name or device name, and and Inklink, it's not going to tell me exact device, but if I know it's running VMware, then I can say, oh, that's my host machine running. Or if it's related to like Texas Instruments or something, maybe I know that device in my house. So this is just a quick way to look up devices and know about them. The other option you need to look here is, again, MAC addresses, layer 2, related to switching. I'm just trying to repeat this and get this. So that's all we need to know from this lesson. And we're going to go ahead and in the next lesson. All right, so now we're moving into layer 4, which is the tree of the OSI model. And we're going to talk about is TCP and what is UDP. So we'll type that T versus UDP. So TCP is what is known as the Transmission Control Protocol. You could think of that as a connection-oriented protocol. And we also have the User Datagram Protocol, and this is a connection-less protocol. So when we have these 2 protocols, one is best suited when it comes to high reliability. That's TCP. TCP is connection-oriented. We want to make a connection, we need high reliability. You can think of something like a website, which is HTTP or HTTPS, or something like SSH or FTP, the file transfer protocol. Those all utilize TCP. When you think about UDP, you might think about something like a streaming service. That's connectionless, or DNS is connectionless, or voice over IP is connectionless. tester. And don't worry about scan. When we get into the scanning section, this will make a lot more sense. But we need to know what TCP and UDP are and define them broadly. So the most commonly used protocol is TCP. Now TCP works on what is called a three-way handshake. Now if we look at the three-way handshake, it's going to look something like this. We're going to first send out a SYN packet, and then we're going to receive back a SYN ACK, and finally we're going to send an ACK packet. Now how does this work? Now you could think of this as an interaction. So let's say you have a friend or a neighbor, and you go to your neighbor and you say hello. That's a SYN. Now SYN ACK is going to be the response. It's going to say, hey SYN, I acknowledge you. That's your neighbor waving hello back. And then you know you are good to go start a conversation. So that's the acknowledgement. Now when we think about this in the terms of ports, now port is a item that can be opened on a machine. It's a way to communicate walls. For example, if you think about HTTP, that's over port 80. If you think about HTTPS, that's over port 443. There's a lot of different protocols, and there are 65,000 plus protocols. So everything related here has to do with these ports. Now let's say that you want to connect to port 443 on a website. You're going to send out a SYN packet to that website. You're going to say, hey, I want to connect to you on port 443. 443 is open and available for connection. They're going to say, hey, you can go ahead and connect to me. And when you want to actually establish that connection, you're going to send that acknowledgement packet back. Now, let's and a tool Shark. This is built into Kali Linux. I'm just going to type in Wireshark, and I'm going to provide an ampersand here just so I have shell access if I need it in the background. And all I'm going to do is packet data. So this is going to be listening Nick, and it's going to say, hey, what's he doing? Let's capture all that data. So we're going to capture that. I'm going to start a capture here. You're going to start to see a bunch of traffic coming through. You can see the different protocols here. You can see UDPs coming through. But we're going to establish a TCP connection. So let's go out to the World Wide Web. And I've got Google up. I'm just going to refresh Google. You're going to see a lot of traffic start coming through. So I'm going to go ahead and just stop this right here. Look at all the data packets that get sent when you're using your computer. This is what's going on in the background. You don't even think about it. So we could see some SYN ACKs there. Those are in the gray. Let's see if we could find a good one. So here is one right here. So what we're going to do, a better one. So we're going to come down to here, and we're going to say, okay, so here are, we're our source IP. This is 192.168.57.139. We're going out to destination 74.125.21.155. We're saying, hey, I've got this port here. I want to connect to your port. So port 443, this is a page. We're sending connection. We're going to go ahead and send the packet back, which is right here. It's going to say ACK. So that's the three-way handshake. Please do remember that come back into play when we get into scanning, and we'll talk about stealth scanning and how we modify the three-way handshake to actually do some. So that is it for this lesson. I will catch you over in the next one. Common protocols. To you. About them briefly on each of these common ports, and the reason I've listed these is because the trace tester, and it's just something that as if one of these show up, it's something that just rings a bell, and you see a scan, it comes back, and you see port 21, you just think, yes, FTP, or you see port 80, HTTP. So you got to start to our. We're going to be able to have common ports memorized. So on the TCP/IP, FTP is the file transfer protocol. You're going to see this in some assessments. You're going to see something called capture the flag, where we run through some test machines. you'll see FTP open quite a bit. So FTP, file transfer protocol, all that means is we can log into this server, we can put a file, or we can get a file off the server. SSH and Telnet kind of play hand in hand. Telnet is the ability to log into a machine remotely. Now, SSH does the same thing. The difference is SSH is encrypted version of that. So with Telnet, you are in clear text, and with SSH, you are encrypted. Now, SMTP, POP3, and IMAP to mail. We're not going to worry too much about mail in this course, but you might see it come back up at some point. So just remember your 25143. DNS. DNS is a way to resolve IP addresses to name. Look at that back to. And so we're at Google here. We've got Google up, but the computer doesn't really know what Google is. The computer is just using nice text like google.com for us, the humans. What's going on the back end is Google actually resolves to an IP address, how the computer knows to get back and forth. Because we don't want to sit there and type in IP addresses, this DNS or domain name system has been implemented for us. So we type in google.com. On the back end, it knows, hey, I want to go out to 179.10.22.34, whatever it is in reality. But this is just a quick way for the computer to begin and into readable access. So going back to our point, we have HTTP and HTTPS. That is what you saw there. Mostly everything is on 4 now or HTTPS. The HTTP on port 80, you'll see sometimes. Remember, that is the non-secure version of the protocol. So S is encrypted, HTTP is not encrypted and not secure. So lastly, SMB ports 139 and 445. Originally, it was just 139. In the later versions of Windows, they've put on 445. You're going to see these ports a lot. This is probably the most common port you're going to see as a pen tester. These relate to file shares. You might also hear this called Samba. There are a few names for it, but when you think of S39 or 445, all the crazy exploits we've had regarding SMB. The most recent one as this course was the WannaCry virus. So WannaCry was the official term of that exploit. That exploit to navigate through networks. So it became very vicious very quick because SMB is open so frequently on network. Now, on the UDP side, we also have DNS over here. DNS is both HTTP and UDP protocol, also HTTP. When it comes to IP, she associated with now the opposite of that. So with the HTTP, you plug into your network, say your home network, and the internet just stops. DHCP, and it just takes the number between your IP address, sums that out for day or week, or is yours. So I want a static IP address, and this specific. Go ahead and give it the IP. How are we going to know that? Right. So later, how to assign it. The simple work and protocol. So you will interact on networks. Not always, but when we do encounter it, then we encounter it, but you'll probably see it again in this course. So that is it in this video. We're going to move on to the OSI model and tie all this together. Then we'll get into a little bit of subnetting, and we'll end this with a refresher on networking, a final. All right, so this whole time we've been talking about networking, and I've been throwing terms at you, and every time I throw a term at you, I try to use the respective layer. So you've heard me say layer 2, layer 3, layer 4, and those all correspond with what is called the OSI model. Now, if you're ever in a network interview, or if you're ever talking to somebody who has experience in networking, or even if you're on the help desk taking tickets, knowing the OSI model is incredibly helpful, and throw layers at you, especially people who have been in the field quite some time, might just say layer 2 instead of a switch, or they might say layer 3 instead of a router. So I'm going to decidedly give you a mnemonic on how to remember it, and just talk about some of the this up from Keith Barker a long time ago. Great trainer, by the way. And this is the mnemonic. So we're going to go PDSPA. And this stands in my head for please do not throw sausage pizza away. Again, that's please do not throw sausage pizza away. So I'm going to put numbers corresponding to the layers in front of it here. And we're going to go ahead and type these out one by one. So on the first layer here, physical. And you can think of a layer as like data cables or like X cables, stuff like that. Something you might plug in, right? That is the physical layer. And we've already talked about layer 2 quite a bit. Layer 2 is the switching, right? And also our MAC addresses. Going down the list, we've got the network layer, which is IP addresses. So routing. The fourth layer is the transport layer, which is TCP UDP, which we have talked about as well. And last few, so the session layer, we've got the session layer, which is just session management. You don't really have to worry too much about this. Presentation layer, about WMV, JPEG, application layer is your application. So laid out, it might be asked. Well, again, we say something like my home layer 2, 3 does the switching, and it does, right? You might as well. You might be asked to and to talk about too with the OSI. Help desk and phone call, and somebody says, you know, my internet, help me. What's the first thing you're going to do? Are you going to ask application level questions? Yeah, probably not. Hey, can you look at the back of the computer? Do you see the cable plugged in? Oh, plugged in. Okay, well, all the way down, and then we try. So we wouldn't start on layer 7, right? We would start and move down. So it's important to know this. This isn't a help desk course by any means, but it's super important to know this, especially if it's been a while since you've seen this network stuff, or even if this is that the OSI model is commonly referred to. Even as a pen tester, I get all kinds of layer layer 3 talk, and you will be sitting in meetings with network engineers who are very, very smart about this stuff, and they're going to know all this lingo. So if you know this lingo, it benefits you, or else you're just going to sit there and wonder what the heck they're talking about. This is a quick, informative method for you. And remember, please do not throw sausage pizza away. That's the easiest way that I remember doing my thing as well. If you've got a move on into other parts of the a method that was shown to me middle of my career, and it just blew my mind. It's really, really fast subnetting method, and I really want to break down for you what subnetting is, why we do it, and then show you the methodology behind it. So if we want to talk about subnetting, if we do something I think will be useful. So we few devices in there, but they're never going to get over this 256 hosts. Okay. So when we come to the subnet cheat sheet, let's break this down a little differently. So we have our host. Start turning the host responds here. We have a /24, and the only reason I'm saying 24 is I'm counting the ones across, right? So we got 24 bits switched 3 and bigger and bigger. Now let's stay away from the ones and zeros. I think it's a little bit complicated. The better way to think about this is to look at the here, and I'm going to replicate this, and then we're going to come back to it. So what I do is we can have a possibility, right? So I'm just making tab, and I'm just going to go over here, and I'm going to hit Control and drag this across till it hits 8. Okay, and then I'm going to do the same thing with 9. I'm going to drag it across. All I'm doing is just making emulating here if we had the possibility of 32 different switched on bits. So imagine one bit is switched on. Imagine all 32 bits are switched on. That's the possibility. Sure, we're going to have an amount of hosts and we're a subnet mask. Okay, so we'll just call it subnet there. We always start here with 128, just like the bits that you saw. You saw the 128 start on the bits. Let's just start also with 128. Now, as you saw, every bit that's switched on, switch a bit on over here, it starts decreasing. So we're going to switch on or 1. And what I actually do is add together, and you can see 128 and 4 is 192, and then you add these two together to be diagonally is the way I actually do it. So 224, 240, 280. Right, so this is just like what you see. A 1 underneath it. If you've got an underneath of it, well, guess what? You've got 128 is 192, and this number keeps growing. Why is this important? Still all ones and zeros, right? Well, let's start thinking about it. If we have a /24 network, we've got 24 bits turned on. Our subnet mask is 255.255.255.0. If we had a /16, it becomes 255.255.0.0. Why? Where are these from? Let me show you this. Okay, for a /8. I'm just tying this in just this right here. Well, this is coming from the number of bits that are turned on. 8 bits turned on. We've got 255, and the rest are zeros. You got 255, 25, the rest are zeros. Come down to this /24, which is that really common subnet that you see, and you've got 255, 255, 255, 0. Now, this is very common, okay? Let's go back to the cheat sheet now. You can see that I've got folder in the subnet. You say, I've got a /1. Well, for this whole area, the whole /128, what? 128.0.0, because that's how it would be. And if you turned on just one bit here and made all of these zeros, guess what? Just the 120 on, the rest would be zeros. Okay, if we had a /14, okay, so 255's automatically flipped on. You have a /8 already, you passed through it. Okay, so you're starting on the second iteration here. /14 corresponds down here to 252. So you'd have a 255.252.0.0. So all this is placeholder to the sheet here. So I make this quick and dirty. This is what I write out when I'm just writing out something quick for an exam, I'll write 32, I'll put the host here, and I'll put the subnet here. So again, if we know that once we cross through 8, 16, 24, 32, that has a 255 in front of it, always will say /27. Well, we've come through 3 columns. Then I know for sure that we've got 255.5.25. something, right? You see this /27, you come down here, the subnet would be 224. Say 28. Okay, 255, 255, 255. Look at the 28, you've got a .240. And this is going to be confusing. Subnetting is not necessarily easy. Number right off the. Now, if you look at the cheat sheet, what you can do here is you just know that you start doubling, and when the bits, every time a bit is, as we go up a number, we take it to the next power. So we've got 8 bits turned off. We take 2 to the 8th power. It's 256. Well, here you go. Look. Come through here, 256. We go to the 9th power, 512, to the 10th power, 1024. It just keeps doubling, okay? That's all you got to think about in your mind, is it keeps doubling. So on an exam, for example, you something like, how many hosts could be potentially in /20 network? And you that where you have it, well, 96, and then we'll get to this, but we have to subtract 2. So, and why is this on? Well, you know, 24, great. Okay, 16 network. That might make sense for you. Or you even see some with a /8 network. It just depends on how telephones. They might just have one, because that's the amount of hosts that fit in there. So what we're after with subnetting is hosts can we fit, and what is the mask that's behind it? So those are questions you might be asked in an exam, and these are questions that you're just going to see. And when you're given addresses, say you're doing a pen test for a client, you might be given something like this. You might be given an IP address, 192.168.1.0/24. Okay, and immediately in your head, you're like, oh, /24, that's standard. There could be up to 256 hosts or 254 hosts or devices in this network. But if they gave you something like 192.168.1.0/20, then you might look at your little chart and say 4,094 hosts. Remember, we're going to subtract 4,094 hosts in this network. Now I know if I'm scanning this, I'm up against a lot more devices potentially than I am in this. Okay, so when a client gives you your subnets, they might just write it out like this. And depending how big your client is, might depend on how big their subnets are for you. For example, I just pen tested a client that was a /16 all the way across. And it looks something like 10.1.0.0/16. Okay, and your subnet mask for that would be something like 255.0.0. And how does this come into play? Well, every time you have a 255, that number's locked in place. That's another way to think about this. So that 10 is always locked down. This 1 is always locked down. Fair game. Meaning we could have 10.1.1.0.1.2.3. We could actually have a 0 here. 0.1.2.3.4. And that's how this number for like a /16 gets so big. Because you have 10.1.0.0 through 255 on the possibilities, which equals 256. Okay, for one range, you get 256. Imagine you have 155 other times, right? And that number gets substantially bigger. And then if you were to have a /8, then of course it gets bigger and bigger. So what you need to realize are a few things here. And you see the /1, /8, again, we call them WACs. WAC 24 is going to be very common. I would say WAC 16 is probably your next common. You might see some weird subnetted networks like this, but typically it's /24. Now, your network ID is typically what is known as your first address, and your broadcast ID is known as your last address. This is not always the case, but it is very common. And let me log Kali machine here and I'll show you. So we have our IP address, 192.168.57.139. And we've got a net mask of 255.255.255.0. What does that tell you from what we just learned? That tells you we have a /24 network. Okay, this is a common network. There are potentially 204 hosts. We're saying that. Why do I keep subtracting 2? Well, we've got a network ID and a broadcast ID or broadcast IP here. Well, what we need to know is we are .139. We can be anywhere from .1 to .254. That's our 254 possibilities. This 0 means we have the flexibility to be any IP. Usually a .0 IP, .5 network ID and your broadcast IP. Okay, usually. So if we were to say something along the line, back to this Excel document, and we were to say something along the lines of this, we have a /24 network, and we want to know how many hosts. We want to know what our network ID is and what our broadcast ID is, or IP is, okay? We would say, okay, and one more. We'll say it's a /24, and the IP starts with 192.168.1.0, okay? Or we can even write it like this, 192.168.1.0/24, delete this, and we'll say, what's our subnet mask? What's our host? What's our network? What's our broadcast? So subnet, you come to your cheat sheet, you say, okay, /24, I already know that I need to be filling in this area here on the X. So I'm just going to come in 255, 255. What's the X? Well, we know to come down this row, 255 here, .0. Okay, and then we've got hosts. I'm just going to expand this a little bit. We've got the hosts. Okay, hosts are right here, 256 hosts. Potentially 254 though, because we always subtract 2 from the host total. So our network ID is usually the first address available to us, 168.1.0. The broadcast is 192.168.1.255, meaning available to us is anything from .1 to .254. Let's take a look at something else. That's a basic example. Let's do like a /28. Let's say we got 192.168.1.0/28. Now what? Well, we've got 16 hosts here. Okay, so our subnet is going to fill in 255.255.255.x, right? Because we're in this row. /28 says it's going to be a 240 when we drop down. Minus 2, 14 hosts. Okay, so non-host would be 192.168.1.0. Again, still the same thing. First address. Last address is going to be what? 192.168.1.15. Does that make sense? In 16 addresses. Usable space is for take out the network and the broadcast. Now, you could only using space. You can in turn that's 192.168.1, and then it starts the same way. Your subnet mask is actually the same because you're using a /28. You come through, you can just copy and paste that. The hosts are still the same. What changes here? Well, your first address, 192.168.1.16, and then your last address, which is 192.168.1.31. So because this is smaller on the /28 side, we can actually have multiple networks within, like, say, a .1, .0, .1, .16, .1, .32. You could have multiple little networks here with only a small amount of hosts. So maybe you have just a few servers in this range, and you have like servers A, B, and C /28, and then you have another one of servers D, C, and E, or D, E, and F, however you want to say it, and you have more in that range. Okay, so this out into different things. And when we see subnets, we see all kinds of stuff: servers, user computers, lists, all things. /23 192.168.1.0/23, but that would be wrong. Why would this be wrong? This is actually going to be a 0, and I'll show you why in a second. So we're no longer locking in this number anymore, right? When we get below the /24, the 255 all the way across for 3 of them, guess what? We're now the ability to change this number other than what's locked in. So let's do a .0. We'll talk about why. Let's hit enter here. Here come in 255 or not locked in. So remember, the lock-in stop. That doesn't happen anymore. So we've got 255, 255. Start at 0 here, and we're going to say the number of hosts that are possible, it's 510. Okay, 512 minus 2. We'll say our network ID is 192.168.0.0, and our broadcast would then be 192.168.1.2. Why? Okay, so we have the possibility now that we're spanning 2 ranges. We've got 510 in this network. Okay, and we have the ability to go between 0 and we've got 2 options now, 0 and 1. So if we were to say another network, if we wanted to get to like a 2, we'd actually have to say 192.168.2.0/23. It would be the same subnet mask, same number of hosts, but then 168.2.0, 192.168.3.255. Like 510 possible hosts in between this. You go think 4, and again 1.1, 1.2, all the way through 254. So that equals 510. Once you've hit that maximum, that 1.255, then guess what? You start at 2, you have a whole new network here. Just like these smaller segments, you get whole new networks on the bigger side as well. So what you need to know is that if I were to put something like a 192.168.1.0/23, that would have fallen into line with the 1 and the 0, and our actual network ID still would have been 0.0, and a 1.255 would have been the broadcast here. And you can double check this. Anytime you're confused, you can double check your CIDR notation. So I'm going to bring over a website that I will show you here. And this is just an IP, it's called ipaddressguide.com. You bring this over and you scroll down just a little, just put in 192.1.0/20, and you can see that it actually corrects me and says the first bit is 192.168.0.0, the last one's 192.168.1.255. Total host is 512 minus 2. Shows you that, again, first IP, last IP, you got your net mask. Very easy to use a CIDR calculator here, or an IP range CIDR as well. So very useful calculators, but if you're using these for like an exam purpose or something along those lines, then using the cheat sheet that I've shown you is super useful. Now, what I want to do is I want to try 3 more subnets. Okay, I'm going to write these out. I'm going to say 192.168.0.0/22, 192.168.1.0/26, and 192.168.1.0/27. I want you to solve these for me. Tell me the subnet mask, the broadcast, Being said, this again is a very complicated topic. I did not pick this up the first time or the second time that I got it. If you're running confused right now, perfectly normal. You can go back and watch this video again, try to pick up more topics, try to understand it. Maybe I'm not the right instructor for this either. I do recommend looking at other resources to completely fill in your knowledge gap if there is one that exists. Another resource that I'll link down is what is called 7-second subnetting. It is very useful. A lot of students have recommended it to me. I'm going to push it forward as well. Go ahead and try to solve this. Understand that what you're after here is just understanding what a subnet is. Okay, when you see something like this, if a client sends you 192.168.1.0/24, you're going to say, hey, okay, I know that there's probably 254 hosts in that network, and I know what I'm working with. If you see this 255.255.255.0, again, you know that you're working with a /24 network. Very standard stuff. That's what we're after. I don't expect you to ever memorize this. I don't have this memorized. Like, I don't come in here and say, you know, a /18 is a 255.255.192.0 network, and it's got 16,384 hosts. I don't do that. Okay, I have a cheat sheet. I'll use a website if I need to. For the most part, what you need to understand is 254 hosts for a /24. If that number has gone up to like a /28, you know you're dealing with less. If that number is lower, like a /16, you know you're dealing with a bigger network. That's really what it comes down to, unless you are working in networking, and then these become more important. But as a pen tester, understanding how to read this, understanding what the subnet is, and just identifying it with very basic measures, this is extremely useful. So I will catch you over in the next video about solving these challenges, and hopefully we got them all right. So I'll see you over there in the next one. All right, so let's solve this challenge together. We've got a 192.168.0.0/22. Why did I write this out this way? Well, similar to the /23. So if we come to a /22, we see that there are 1,024 hosts, which means we have a possibility of 1,022, right? And all we need to do is fill in the blank on the X. 55.255.252.0. We come across, we know our first IP here, or ID, is 192.168.0.0, first address possible. Now, if we think about this, we can kind of do this mentally, and we can think, okay, there's probably 50 or so hosts in a network, and we've got 1,000 or so hosts here. Well, that's going to be about 4, right? 4 ranges, because we've got 1,000 divided by 250. So I'm going to go ahead and go 0, 2, 3. That's 4 total. We'd say 192.168.3.255. And hopefully that math makes sense. So dot 1 through 254, dot 1 through 254, dot 1 through 254, dot 3, dot 1 through 254. That equals about 1,022 hosts. Okay, actually, I lied to you. The only 2 we're taking off are 0 and 255. You actually have .0 through 255, 1.0 through 255, all the way. We're only subtracting these 2. So if you do that math, that will add up to 1022. Okay, so a /26, we've got a 255.255.255.192. Fill in the blanks, fill in the X's. 64 hosts, well, we got 62 in reality. And we're going to say 192.168.0.2.168.60. Network, we could start with a 64/26, 4 as the network ID, and then 127 as the broadcast. And lastly, 255.255.254 for a /27. We've got 30 potential hosts, 32 minus 2, 192.168.1.0. And then we're going to do 192.168. Same thing here. If we wanted to create a second network, we could. We could say 1.32/27. Let's start at 32. And this one would end at 63. We can make however many networks within that, 4 to 8, I think 8 different segmented networks with the /27. So that is it. Again, as I said last video, this can be confusing, and all we're taking away is in a row. Fives you see on your screen, hosts. Okay, and just understand how to read this. That's all you need to take away. Again, I'm going to provide additional resources as I provided in the last video. Go review them. If you don't understand them, you can always come to the Discord channel. You can always ask Q&A questions. This is not an easy topic, but it is a topic that I had to show you as part of networking. All right, so in order to be successful in this course, we are going to be utilizing what is called a virtual machine. Now, virtual machines are known as VMs for short. And a VM is just a machine. And to get this one instance that you see here on top of my Windows 10, and you can see if I scroll up that I have a Windows 10 machine. I also have a Linux machine sitting here. If I were to do this, you can see that I'm actually running here a Windows machine in the back. This is my wife and I, and you come through here, we just blow it back up, and we're back inside of our machine. So a virtual machine is just a machine inside of a machine. So what we're going to be utilizing this to build out labs. That way we don't have to actually have a bunch of hardware. We can just use this for our core, what we need to on top of our own machine already. Now, this can get resource intense. So if you are only utilizing something like 8 gigabytes of RAM, then you might have some issues with this, but you can still follow along. When we get into the Active Directory portion, you might run into issues if you do not have at least 16 gigabytes of RAM to utilize. But we'll worry about that when we get there. There's still plenty of ways to follow along throughout this whole course. So another thing to note is that I use VMs every single day. This machine that you see here is actually my day-to-day pen testing machine. So I run a Kali Linux instance on top of my Windows machine and utilize that to do penetration testing. So I'm going to demonstrate that to you and how we're going to build out our labs. And a lot of us in the industry run through VMs as opposed to running it directly on Metal or on a machine. So in order to utilize virtual machines, we first need some sort of virtual machine software to play these. So there are two different ways that we can do this. If you are on a Windows machine or a Linux machine, you can utilize VMware Workstation Player. Now, if you type in VMware Workstation Player in Google, the first one here that says download VMware Workstation Player, you just click on that. Mac environment, you're going to be utilizing Oracle VirtualBox. So if you type in Oracle VirtualBox, you come here and you go to downloads. You have your option there as well. So in this course, I will be using VMware Workstation Player. I'm going to be running it on top of Windows. If you are using Mac, that is absolutely fine. You're going to be following along just the same. All you need to be able to do is follow the same instructions that I give you, and you will be A-OK. So if you scroll down here, you can see try Workstation Player for Windows or try Workstation Player for Linux. Go ahead and just select download now. That should bring up a download. Save it. If you're doing VirtualBox, go ahead and download for OS X. I will download the Windows version just so that we can see what that looks like as well. So I'll save both of these. So let's view our downloads, and we've got VMware Workstation Player here. I'm going to go ahead and open this one, and we're going to install this. And this will be very point and click. So next, accept the agreement, possibly give away our first child. Yeah, we should go ahead and install the enhanced keyboard driver while we have this. And then we don't need to join any improvement programs or check for product update. That's okay. We will install start menu. You check your preferences as you like it. I'm just going to install this, and this should just finish here in just a second. Or two, and we're going to go ahead and hit finish. And it's going to want a restart to take effect and restart your system. I'm going to no right now. Let's go ahead and install VirtualBox if you are a Mac user. We'll hit next. And install. Point and click with the installation. Select install and it do pop up. And then we can start Oracle VM if we want. Let's go ahead and just start that. This is what Oracle VM looks like. And let's see if we can start the VMware player here, even though we need a restart. And this is what the player looks like. So here you can see that we have virtual machines. We can create new virtual machines, open ones, etc. We'll get into that in the next video. So again, if you are Linux, this is probably what your view is going to look like for the rest of the time. If you are using Oracle on a Mac, this is what your view is going to look like. Another side pro tip here is that I am using Workstation. I might utilize this in some instances throughout the course. Other instances, I'll be utilizing the Workstation player. They are not much of a difference, especially in the beginning. When we get into the Active Directory portion, it might actually be worth it for you all to download the VM trial, because it trials 30 days, and you can utilize that to get through some sections and actually have nice little windows here to be clean and just have a pro edition. You can do everything that I'm going to show you in the open VMware several times, but this won't look like this nice clean layout where you can transfer between machines like I can do just here. So with that being said, let's go ahead and move on to the next video. We're going to be installing Kali Linux onto our VMware Workstation player.
Now that we've installed VMware or VirtualBox, we need to install Linux. We're going to be using a version of Linux throughout this course. This version of Linux is a Debian-based distribution, which is geared towards hacking and penetration testing. So a special version of Linux allows us to have all the tools in one place that will allow us to hack without having to download these tools and install them on our own custom Linux distribution. So it's all kind of nicely built into one package. So to type you should think all below as well. You should be able to we're just going to go ahead and click on this virtual machine option, and that's going to take us down just a little bit here. What you're going to do is you're going to download the respective version that you need. So if you need VMware, you download VMware. If you're using VirtualBox, go ahead and download the VirtualBox one. Now they have a direct download, which is a 7-zip, and they also have a torrent if you know how to torrent. What you do is go ahead and download the file that you need, and while you're doing that, if you download directly, you're also going to need a tool called 7-zip or a way to unzip this file. So go ahead and start your download. While it's downloading, go ahead and navigate to 7-zip. So if you go to Google and you look at 7-zip, you'll see this page here come up. You just go to download. Here you're going to download the file that is for your respective system. So here I'm using Windows on 64-bit. I would download this executable right here. Now, if you're running on Linux, here's where you download Linux. Mac OS, here's where you download for Mac OS. Very straightforward. I've already got this installed, but what you need to do is just download this and literally click next through it. Make sure you get it installed. Go ahead and pause the video. Once that is in 7-zip, that is, and once you have the actual Kali image downloaded, go ahead and unpause the video. I'll be here waiting for you. Okay, so your next step should look something like this. you have your set file open, you should see a folder located in there. And the easy thing is to drop this. Also right click and extract. Where we want to extract it. Created a folder called Kali. I'm just going to grab this and I'm going to drag it over. And it's going to take a minute here, just a few seconds honestly, to unzip. The file size of this one, at least for the VMware version, is around 11 gigabytes or 11 gigabytes. So make sure you have the space on your hard drive in order to do this. Now, once you have it unzipped, you can go ahead and just double click in here. You'll see a bunch of files. If you have VMware installed, you can actually just double click on this VMX file and that should open things up for you. I'm just going to show you the other way around doing this as well. So with VMware Workstation Player open, what you're going to want to do is go to Open a Virtual Machine. And in the folder that you have, you should see this VMX file as well. Click it, or you could just open it. What's going to happen is it's going to file here, and you're going to edit this virtual machine settings. Once you have it loaded, click settings, and in here you want to first change the amount of RAM that we have. Now, this is dependent on your system. If you have RAM or maybe even 16 gigs RAM, you might want to try leaving it at 2 at first. I'm going to bump mine up to 4 gigs, which is 49. And I have 128 gigs of RAM, so I have more than enough space to allocate for this. But again, if you're on like 8 gigs of RAM, probably not the best beyond 2. Honestly, at 1, maybe 2, so it works. The other thing you're going to want to make sure of is that you're running on NAT network. So if you click on network, ensure that it says NAT, and that's selected. Once that's selected, go ahead and hit OK. And then you're just hit play virtual machine. When it asks you what to do, just say I copied it. Now from here, it's going to take a minute. You can just let this run through. It'll boot on its own. Once you are presented with the login screen, go ahead and pause the video. But until then, pause, and I'll meet you back when you're at the login screen. I'm going to make this a little bit bigger just so we. And from here, what I'm going to do is in the username of Kali, K-A-L-I, and the password of Kali, K-A-L-I, enter. And if you see this screen, congratulations, you have successfully installed Kali Linux, and you now have it. In later videos, we're going to cover what we're going to be doing and how to use this and how to use Linux and all this. But for now, pat yourself on the back. You've got Linux installed, and we're going to pause here and move on to video.
Okay, so this video updates we need to make to VirtualBox for quality of life. So if you're not using VirtualBox, skip this video. If you are, buckle in. We just need to do a couple of quick updates and then we should be good for the rest of the course. So go ahead and go out to Google and Google VirtualBox Extension Pack. What it's going to bring up is just the downloads page of VirtualBox. So we're going to want to go here. And on this page, towards the middle, you'll see that there is a VirtualBox extension pack here. Click all supported platforms. That will automatically download the file that we need. So once that is downloaded, and pause if you need to, go ahead and open VirtualBox. You can come in here, and up at the top, we're going to go ahead and click on Preferences. And from here, we are interested in extensions. See extensions right here. Go ahead and click on that. There's a little plus sign. We're going to go ahead and click. And then you should have your downloads right here. So we're going to take the downloads and just go ahead and install that. Hit install. Read this. Give away your firstborn. Accept all the terms. And you should be good. Very quick install. Okay. The second thing is we need to come to the one tab up here above, which is Network. We're going to go ahead and hit the Network button, or this Add button called a NAT network. Okay, and we're going to come in here and we're going to double click. And you can go ahead and keep these defaults, I'm going to actually change to 192.168.57.0 because that's what's going to be used through the rest of the course. And that is what the notation of my Kali machine, Keyoptrix, which we'll see later, etc., all fell into this 57.0. So we're going to go ahead and keep it on this NAT network. Make sure you support DHCP. Go ahead and just hit OK. Hit OK. And then for a machine, and make sure any machine that you use, make sure you set it to NAT network if you're using this mail machine I have here. You can just click settings, go to network, and head to network, right? And that name right here is name network. Set it up. You have a Kali machine running later, and you have Keyoptrix box running, or you build out an Active Directory lab. You need to make sure that you're running that NAT network so that all of the machines are on the same subnet. If you don't, you might run into a situation where the same IP comes up for the same machine, and then they're with each other, or you get on different networks, and weird stuff happens. Make sure, again, that it's imperative that you're setting that NAT network for every single machine that you're setting up. So with that said, we're going to go ahead and move on to video in this section. The first thing I'll do, get started with any commands or anything like that, is just take a look around Kali Linux and kind of demonstrate why a pen tester or ethical hacker might use this distribution of Linux. Now, throughout the course, as stated in the last video, you might see videos on some of the old as is. You just might see a different feel to some of the Kali interface, but all the commands I'm going to show you, everything that we do is going to be the same. Let's take a look and just explore Kali Linux just for a bit. So if we come up here into the corner and we just click on the logo, nothing's going to be essentially, we've got a text editor, we've which Fire. We've got some other tools, Fire, docs. We can see that we have in the section go and but in the of how a hack might go down. So information gathering is your step to information gathering. Click into these and go deeper if you wanted to, or SMB or open source intelligence. All of built-in tools. We want to do tools are built in. So in start terminal. But more so online how we can use hopefully. So in the next video this course, and we'll talk options that you have. No feature. All right, so what was that in the early user called root the machine. Now we're running as a user Kali, so we don't have root privileges as an improved security. As the root user. So for super user do. Now with run a command elevated. I want to run this as in this as root. Why is that important? Look at an example. Shadow file. You this Etsy shadow, and you don't have to follow. You don't have to really understand. You've never seen Linux. Have the thing. If I was the root user or person who had elevated privileges, I could say sudo cat shadow like this. Okay, and it's going to say, what is your password for Kali? I'm going to go ahead and say Kali, K-A-L-I, hit enter, and now I can see that I have access to this file. And this file is very sensitive. We'll talk about this later on in the course, but it's a file, okay? So when we're looking at it, I ran that command as the root user. As the root user, I'm able to see, okay, this file now. Why or what's going on here? Well, we're running that specific command, right? And we're still staying as scenario. So there will be times where something in this might or you without sudo, but you notice something doesn't work. So best is saying go ahead and run mostly everything going in this course. That's not best practice overall. Usually you should run things just as a regular user. If you get permissions blocked, then run sudo as necessary. Now, the other thing to point out, and we'll talk about this again later on, but why this is because it is part of what's called a sudo, meaning we can't have the permission. Not any user in here. Say we made a new user and we just called the user John. We can't just take John and just go ahead and just run these commands as root. No, John has to have the. So you can think of Kali as being an administrator, but only when we utilize that access or that privilege. Is come in here and say Swift user dash, just like that, and then I'll press into root. Now you can see, and that's only for this instance. You want to demonstrate if you want change your password, log out, and log back as root. Run through the course as root. That is available for a user that is comfortable running as root. As needed. But this is a quick way to switch into root if you need to. But we can go up and that of root is only good for this tab here. So we're going to be brought back right back. So just keep note of this when you're in this. If you see something again, try running it. Working. If each window. Very, very in your looking at around the file system from and diving into